Okay, good evening. So last week we started this section, proof of silence, okay. Proof of inequalities, okay, now silence. Proven inequalities. So I told you there are two types of there are inequality questions. One is solving inequalities, and the other one is proving of. How do we prove an inequality? Silence, remain silence now. Okay. So how do we prove an inequality? If they assume that you are supposed to show that A is greater than B. Assume that you are supposed to show that A is greater than B. So when A is greater than B, what we have to do here is, I told you, we write a particular expression as P such that A minus B. So B I'm taking to this side, I'm writing it as A minus B. And then what I have to do is somehow, after simplifying this expression, I need to show that P is greater than 0. Because if you can show that P is greater than 0, so then it's A minus B which is greater than 0. So then I get A is greater than B. So when A minus B is greater than 0, I can get the answer that A is greater than B. So this is the basic flow that how you can prove an inequality. So as an example, if we take something like A squared, we're supposed to show that A squared plus 2B squared is greater or equal than 2AB. Then according to this method, what we do is, we write an expression P is equal to A squared plus 2B squared minus 2AB. And then I told you these A, B are real numbers. So when A and B are real numbers, we know that this is positive and this is positive. Because A squared, a square number is anyways positive. We know this is positive and this is positive. So what disturbs us of saying that this entire expression is positive, or what restricts us by saying that this entire expression is positive, is this minus 2AB term. Because I can't say that this is positive. So what did we do? We have to think of a way how we can combine this with these two such that I can say it's a positive term. It's a positive, like it's positive. For that purpose, like we have minus 2AB, so I'm taking A squared minus 2AB, and I'm taking 1B squared. I have 2B squareds, I'm taking 1, and then we have the remaining B squared. Then it is clear A squared minus 2AB plus B squared. This one is equal to A minus B squared. So then the expression that I'm simplifying, I can say that this is equal to A minus B squared plus B squared. So A minus B squared is a square term. A square term is always greater or equal to 0. B squared is a square, it's even greater or equal to 0. So when we have the addition of two positive values, that is P is greater or equal to 0. So what is P? P is that the expression I have taken, A squared plus 2B squared minus 2AB is greater or equal to 0, which means I can say when I take this to this side, A squared plus 2B squared is greater or equal to 2AB. So this is how simply you prove an inequality. Think of a way that how you can do this. Especially in this case, you know, when we have square terms, when we have something like plus 2, so then we can say it's positive. When we have square terms and when we have these plus constants, positive numbers, you can say it's positive. So if we have terms like this minus 2AB, you can't say it's positive. So what we do is we combine these with the remaining terms to end up in a position like this. So we can clearly say that this is even positive and this is even positive. Okay, so this is where we stopped last week. So let's start with this question. Do this. Write the question. A and B are real numbers. Look at the board. A and B are real numbers. Show that A squared plus B squared is greater or equal to AB. B are real numbers. Show that A squared plus B squared is greater or equal to AB. Greater or equal to AB. Okay, so what we can do here is if you take this as P, it's A squared plus B squared minus AB. Okay, so this is, now listen, I'll give a similar question so you can do this alone. This is what I want you to practice. ඒ කියන්නේ මෙන්න මෙහෙම එකක් තියෙනවා අපි ගණන් හිතද්දී මේ ඕන ගානක් හිතද්දී ගානක පොයින්ට් එකක් තියෙනවා අපි හිතන්න ඕනේ. So when you are thinking the logic of a problem, when you are thinking of a way how to solve a problem, there is a particular point that we have to think. හරිද? එතනින් තමයි අපි අල්ලගන්නේ. පොයින්ට් එක අපි අල්ලගන්නේ එතනින්. So in this one, what I can say, I told you A squared is anyways positive, B squared is anyway positive. So what restricts us from saying that this is positive is this minus AB. So in the previous questions, you can remember when we had this AB here, when we had the products, what did we do? We somehow tried to put this product inside to a square. No? මේක අනිත් ඒවල මතක ඇති ඔය අපිට 2AB AB වගේ තිබ්බහම මොකද්ද කරේ අපි AB කියන එක මේ ස්ක්වයර් එකක් ඇතුළට දැම්මා we put these AB terms like 2AB these terms inside to a square. But if you look at those, if this was something like 2AB, මෙන්න මේක 2AB වුණා නම් if this was something like 2AB, then I admit then you can write A squared minus 2AB plus B squared. It's A minus B squared. No? If this was 2AB, we can do something. මෙතන තියෙන්නේ 2AB නම් මොන හරි කරන්න පුළුවන්. So that is the point that I need you to think. If we had 2AB, then we can factorize this as a complete square. Okay, now it is clear. That means I need a 2AB here. I need a coefficient 2 here. So I need a coefficient 2 here. So when you need a coefficient 2, you can't just put a coefficient 2 here and write it in this way. එහෙම ලියන්න බෑ. ඔයාලට මෙතනට දෙකක් ඕනි කියලා එහෙම නිකන් දෙකක් එහෙම දාන්න බෑ. Mathematically it should be correct. For example, if you are writing x is equal to a plus b, next step you can't write that x is equal to a plus 2b. That is wrong. But you want a 2 here. For that purpose, I'm multiplying the entire expression by 2. I'm multiplying the entire expression by 2. So what is my intention? So then I get this 2ab term. But even this is mathematically wrong. So හිතන්න ඔයාට x equals 2 තියෙනවා නම් ඊළඟ step එකට ආවහම x equals make a 2 into 2 x equals 4 කියලා. Can you write in that way? No, you can't write in that way. You are starting with x equals 2. Here it's x equals 4. You are starting with x equals 2 and you are coming to x equals 4. එහෙම ලියන්න පුළුවන්ද? But it's wrong. So here, why did I multiply by 2? Because I wanted to have a 2ab. To take out the impact of 2, what can I do? I can divide this by 2. And now there's no any impact because you can see these two cancel off. So it's the same thing. ඒක නිකන් මෙන්න මෙහෙම එකක් මම කරේ when x is equal to 4, I have considered x is equal to 4 into 2, but you can't just multiply, then I divide it by 2. Clear? Okay, hands up if this step is clear. This step I multiplied by 2 and I divided by 2. Hands up. This one is clear. Okay. So then come to the next step. Now write the next step. So when you come to the next step, we have in half into 2. Okay. Okay, now when you come to the next step, ඊළඟ step එකට ආවහම දැන් මෙන්න මෙයාට මෙයා කපලා ආයෙ මේක ලියන්න එපා. So there's a reason why you did this. No, you don't cancel this and again write a squared plus b squared. There's a reason why you put 2 here. Why you put 2 here is because you want to have this 2ab, 2a squared, 2b squared minus 2ab. Clear? Okay, now I know like we have solved these kinds of problems even last week. I'm taking 1a squared. I'm taking 1a squared minus 2ab and 1b squared one a squared is remaining, and one b squared is remaining. So after writing in this way, the term that disturbs us by saying that this is positive was this 2ab1, then this becomes a minus b squared. So then p is equal to half into a minus b squared, a squared plus b squared. Clear? So then it is clear. When we have all squared terms, the entire expression is positive. But since it's square, it's greater or equal. When there are only squares, there's a equal 0 part. Okay, then you might say that p is greater or equal to 0. So when I write this, normally students ask me, so what happened to this half? What happened to this half? බාගෙට මොකද උනේ? So tell me, so this one, the expression inside the bracket is positive, no? When you divide a positive number by 2, it's even. Positive number එකක් දෙකෙන් බෙදුවා මෙන්න number එකත් it's positive, no? So then you don't have to consider about this half. Like when you have this expression, when you divide a positive number by 2, even you are getting a positive number, so you don't have to consider this one. And then you get p is greater than 0. So then you can write what is p, a squared plus b squared minus ab. So a squared plus b squared is greater or equal than ab. Clear? So the thing in the logic behind this is I want a 2ab. In order to put this inside a square, I need a 2ab. So I'm multiplying by 2 to take out the impact mathematically. So I divide it by 2. Clear? Okay, do this and then try question number 3 in the tute. First do this, complete the work, and then try question number 3 in the tute. Can do question number 3 in the tute. Same thing, same calculation, that same we had to think. Even here you got AB, BC and CA terms. Silence, do the work. Question number 3 in the tute. Okay, so here even take an expression or name this expression as a squared, b squared, c squared, and I got minus ab, minus bc and minus ca. So same thinking, like somehow you can put this inside to a square if it is in terms of 2ab, 2bc and 2ca. For that purpose, I'll multiply this entire 1 by 2 and divide it by 2. So I get a squared, b squared, c squared minus ab minus bc minus ca. So then multiply it by 2, you get 2a squared, 2b squared, 2c squared minus 2ab minus 2bc and minus 2ca. Okay, so when I multiply this by 2, you might get the feeling of this. Like you might say, Miss, we only wanted a 2 here. So when you multiply the entire term by 2, even these becomes 2a squared. So these are square terms, no? So it's okay. Even this becomes 3a squared, 4a squared. That is okay because whatever the coefficient we have here, a squared, b squared, c squared are positive terms. Again, what make it 2 square, 2a squared, 3a squared, මොකක්කාවත් අවුලක් නැහැ. මොකද ඒකේ it's anyway positive. තේරුණා? මේවා positive terms. අපි consider කරන්න ඕනේ this ab terms, a b b c c a terms. Because that is the reason what disturbs me or restricts me of saying that this is positive. ඒක නිසා තමයි කියන්න බැරි that this is positive. Okay, now look at this. What happens here is if you take 1a squared, you take that minus 2ab and you take 1b squared. And then if you take this another b squared, you take this minus 2bc and you take a c squared. I'm taking the remaining a squared because there were two a squareds. And I only got one here. I'm taking the other one. And I'm taking the minus 2ca and the remaining c squared. So now it is clear. You have taken both the a squared terms, the b squared terms, and the c squared terms. So now when you look at this, it's clear. This is a minus b squared. This becomes b minus c squared. And this becomes A minus C. So you can either write it as A minus C or C minus A, that both is okay. So what is M? My M is equal to half into A minus B squared, B minus C squared plus A minus C squared. Clear? So we have in all positive terms. When we have squared, you can say this is greater or equal, all are greater or equal. Then I can say that this is silence greater or equal, which means M is greater or equal, because even though it's half, there's no difference when you divide a positive number by half. You get A squared plus B squared plus C squared minus AB minus BC minus CA is greater or equal to 0. A squared plus B squared plus C squared, you get that this is greater or equal to AB silence BC plus CA. Same thinking that you have to divide by 2 and multiply by 2. Okay, hands up who got this answer, question number 3. Okay, good. Now think of question number 5. Do question number 5. Okay, now look at this. I give this question especially because of two reasons, and I want to explain like some common errors students are doing in this question. So when we have, now listen properly, I'll come up to a certain stage and I'll again give you time to solve this equation. Okay, now listen, everyone, look at the board, look at the board. Okay, I'll come to a certain step and I'll give you time to solve it. So this one is like the only simplification you can do, let's say, that I'm supposed to show A over 2 is greater than B. So I can take this 2 here and I can show that A is greater than 2B. That is okay. Because you can multiply it both sides by both sides of the inequality by a positive number. In apita A over 2 is greater than B කියලා පෙන්නන්න තියෙද්දී we can multiply it by 2 and show that A is greater than 2B. That is okay. Okay, because there's no any mathematical mistake here. I'm multiplying both sides by 2. Or you can multiply it by 2 and you can send this to this side. So that is okay, but I won't do that. You can do that. If you want, you can change the inequality rather than proving this. You are going to prove that A plus B is greater than this one. So rather than proving this one, you can change it. Okay, so I'm not doing that one, but you can do it. If you are not doing any mathematical errors, if it is mathematically correct, you can change the inequality. But that is not the problem. So these are the common mistakes I see in this question. What students do is you can take this, let's name it as K. It's A plus B over 2 minus root AB. So one mistake that students do is, when you are supposed to show that A is greater than B, when you are supposed to show that A is greater than B, you can't take that A squared, you can't show that A squared is greater than B squared. You can't do that. When you are supposed to prove this one, you have to prove this one. You can't prove that A squared is greater than B squared. That is wrong, because I told you the square, when we have to square either sides of the inequality, that is a different story. And so A is greater than B, you can't show that A squared is greater than B squared. That is wrong. So first thing, if you are going to show that this entire squared is greater than the square of this, that's wrong. Okay, that is the first thing. The second thing is when you write this one, then I see students square in both sides. K squared and they are squaring this side. Okay, so that is even wrong. What am I supposed to show? I need to simplify K. I need to simplify K and show that it is greater or equal to 0. Mama pennandone K is greater or equal to 0. Not K squared. K squared is equal or greater than 0. If it is squared, it's always, it's positive. Okay, so when it is squared, it's always positive. So when you are supposed to show K is greater than 0, keep in mind you can't square it. You have to work with k. Okay, so those are the main two mistakes that students do. Some square either sides of the inequality, sorry, both sides of the inequality, and rather than showing a is greater than b, they are trying to show that a squared is greater than b squared. That is wrong. You can't do it. Okay, and this one, when you are supposed to work, when you are supposed to show that k is greater than zero, you can't show that k squared is greater than zero. You have to work with k. You have to work with k. Okay, so I'm taking this common denominator a plus b minus 2 times ab. Okay, now I want you to simplify this. I'll give a small hint. Think of writing this a as a square. Think of writing this a and b as a square. Okay, now try to do this. Think of writing a and b as a square number, as a square. Then you can see a particular expression that has been created in the numerator. Think of a way how you can write a as a square. Silence, silence, and do it. Think it. Like, don't wait till I do it. Everyone, even though you are a newcomer, think of writing a as a square. Then you will see a particular expression here. Okay, I have k. Now tell me, if I ask you to write 9, listen. If I ask you to write 9 as a square, how can you write 9 as a square? It's 3 squared. If I ask you to write 4 as a square, how can you write it? 2 square. If I ask you to write 5 as a square, how can you write 5 as a square? We learned this. 5 can be written as a square. How can we write it? The square of root 5. Remember, I told you, any number can be written as a square using its root. So I can write a as the square of root a. I can write b as the square of root b. Then here I have root ab can be splitted into two terms, root a into root b. Okay, now look at this. You have the square of root a, you have the square of root b minus 2 times the product of the two terms. You have this squared minus 2 times the product of the two terms. Tell me, what is in the numerator? What is this in the numerator? Root a. Tell me, you can see the square of this one. You have to see the square of this one minus 2 times the product. What is this? Root a minus root b squared. So here the numerator get reduced up to root a minus root b squared over 2. So this is root a minus root b squared. So when it is a square term, you can say that it is greater or equal to 0. So what happened here? Root a squared plus root b squared plus 2 minus 2 times the product of the two terms. It's root a minus root b squared. Clear? So this is how you can do this. It's root a minus root b squared. Okay, then you can say that k is greater than 0. K is greater or equal to 0. And then write the final answer. What is the final answer? A plus b over 2 minus root ab greater or equal to 0. Then I get a plus b over 2 is greater or equal to root ab. Clear? Is greater or equal to root ab. So that is how you do it. A good question that you have to think of a way that how you can write this as a square term. Clear? Okay, so using the same thing, now think of question number 6 that you can do alone. The first part of question number 6, you can do it alone. It's quite easy. After this, start question number 6. First do the first part of question number 6, then I'll explain the deducing part. Hands up who are new to the class the very first day. Anyone? No? Okay. We have an exam today. A good day to come. Okay, do this after this. To question number 6. Do the first part. Everyone can do that. First part. Silence, do the work. Do question number 6 that you can do. Silence, silence, can't talk. Just do the work. They have given x is a positive real number. Special case. It's positive real number. We are supposed to show that x plus 1 over x is greater or equal to 2. Do the same thing. You can easily do it. You take all the terms to one side and take a common denominator. You end up with the answer. Lazy make Okay, so how can you do this? So it's quite easy. I need the entire class to do this. So if you take all these to one side, it's x plus 1 over x minus 2. Now take x as the common denominator. So when you take x as the common denominator, it's x squared plus 1 minus 2x. So what is in the numerator? X squared minus 2x plus 1 over x. So in this case, like they have given that x is a positive real number. It's not just a real number, it's a positive real number. So you know the denominator is positive. Okay, but when you look at the numerator, it's x squared minus 2x plus 1. Someone familiar, no? Who is this? X squared minus 2x plus 1, a familiar one. Who is this? X minus 1 complete square. No? So here we have the complete square of x minus 1. Which means that you have written the numerator as a square. You have written the numerator as a square. Okay, now it is clear. Your denominator is positive and your numerator is positive, but it is equal, even equal to 0. So when the numerator is positive and the denominator is positive, the entire term is positive. But since there's a equal 0, I consider p is equal to greater than 0. So p is equal or greater than 0. Clear? Okay, so what is p? What is p? It's x plus 1 over x minus 2 is equal or greater than 0. I get x plus 1 over x is equal or greater than 2. So I get the answer this way. For the future purpose, I'll name this as 1. Okay, hands up who got this answer. Everyone got it? Hands up? Okay, good. Now look at the remaining part. They are asking hence deduce an additional part. No. What is the question? Hence deduce. Hence deduce. Okay, now they are asking hence deduce. Hands up who have heard this word deduce previously. Deduce. D-E-D-U-C. Not deduce, deduce. Hands up who have heard that word? Okay. So did you, like you hear that in O levels or nothing? Or did you know? You had that? Okay. So you know what is the meaning of deduce? The simplest meaning of deduce is using a previously obtained result. So what is the meaning of deduce? Using a previously obtained result. ඒ කියන්නේ මෙන්න මේ ප්‍රශ්නය ඇතුලේ මම මෙන්න මේක දැන් මෙන්න මේ result එක පෙන්නුවානේ. So using this result. So that is the meaning of deduce. If we have to use a previously obtained result, you can write this. Okay, so now if I ask you to prove when y is a positive number, if I ask you to prove that y plus 1 over y is greater than 2, if I ask you to prove this, do you agree that you have to follow the same steps? The මම ඔයාලට කිව්වොත් මේක පෙන්වන්න කියලා, you have to follow the same steps, no? Is it clear? The only change is here x has been changed into y. If I ask you to prove this, you have to write the exact steps. The only change will be x has been changed into y. Okay, හොඳයි නිදිමත ඉන්නවා. You're supposed to write a paper today, full chill එකකින් ඉන්න ඕනේ. Not chill, kick එකකින් ඉන්න ඕනේ. Clear? Okay. In maths, we have something like this. Let's say Okay, if we have to follow the same steps, or if we have to do this, if we have to solve this problem in the same way that we have done this. So if we have to take a result in the same way that we have taken this result, you don't have to do it twice. ඔයාට මේක දෙපාරක් කරන්න ඕනේ නැහැ. මේක කරන්න කිව්වනම් මේ විදිහටමනේ ගන්න තියෙන්නේ. Then you don't have to do it twice. You can write this word, just write similarly, write the word similarly, and then you can straight away write this answer. Clear? Then you don't have to do it again. Then you can write similarly, and then you can directly get this answer. So now it is clear. All these are positive. When this is positive, this is greater than 2, it's even positive. This is even positive. All are positive. So you can multiply the two inequalities. Because the two inequalities are positive, you can multiply both sides of the inequality. Because it's positive. So when you multiply x plus 1 over x multiplied by y plus 1 over y is equal or greater than 2 into 2. So you get the answer. You get the answer x plus 1 over x times y plus 1 over y is greater or equal than. Okay, so make sure like you can only multiply the inequality in this way because you know both these sides are positive. Okay, you can multiply the inequality in this way because you know that both sides are positive. Make it positive, make it all are positive, so you can multiply. So you can write it similarly and get the answer. Okay, write this in a red pen, put a red star mark and write in a red pen. Put a red star mark and write in a red pen. Try this. If we have to use the same method, if we have to use the same method, if we have to use the same method to obtain a similar result, to obtain a similar result, to obtain a similar result in the same problem, in the same problem, instead of doing it again, or instead of repeating it or doing it again, you can write anything. Instead of repeating it or doing it again, we can write, so use a black pen. You anyways writing in the red pen, no, so use a black pen. We can write similarly, just that word. We can write similarly, back to the red pen and directly write that result. We can write similarly and directly take that result to write that result. Okay, next line, write this word using a black pen, deduce. Next line, deduce. Word deduce. In front of that, write this. In front of deduce, write using a previously obtained result. Using a previously obtained result. Using a previously obtained result. Okay, so always keep in mind you can use this word similarly only inside the same question. Let's say you are solving a problem day before yesterday, you have solved this one, and today you can't come and write similarly this answer. Okay, so it's inside the same question, not even inside the same paper. Inside the same question, only you can use this. Okay, so at the beginning of the paper you are getting this, and in the last question you can't write similarly and write this answer. Okay, only same question. Okay, complete the work. Write similarly, then I'll put another question. You do this, complete the work. Silence, silence. Okay, the question is when x, y, z are positive real numbers, show that this one. First, show this one. Hence, prove Q8 in the dude. So first you need to show this one. Hence, prove question number 8 in the dude. Hence, prove question number 8 in the dude. No, silence, silence. I have given a question. When x, y, z are positive real numbers, first show this one. X squared, y squared over xy is greater than 2. Hence, prove question number 8 in the dude. Hence, prove question number 8 in the dude. Silence, silence, silence. Do the work. Easy question. I need the entire class to do it. Okay, done. Okay, so first thing, name this expression as P. Silence, silence. Kadanatan vadagaran. X squared plus y squared over xy are minus 2. So when you take this xy as a common denominator, you get x squared plus y squared minus 2xy. So what is in the numerator? It's x minus y squared over xy. Clear? X minus y squared over xy. So what is this? It's x minus y squared. So now it is clear even in the denominator xy, because x and y are positive real numbers. So the xy is anyways greater than 0. When it is a square, it's always greater or equal to 0. When it is a square, we can say that it's greater than 0. Okay. So that gives me the answer that P is greater or equal to 0. That gives me the answer that P is greater or equal to 0. So what is P? It's x squared plus y squared over xy minus 2 is greater or equal to 0, gives you the answer that x squared plus y squared over xy is greater or equal to 2. Okay, so this is my first one. So then I told you, wait first, hands up who got this one, so you should get it. Okay, then I told you, like, when you look at the question, it's the same result, but with different things. Here we got x squared, y squared. In the next one, it's y squared, z squared. And the last one, it's x squared and z squared. So then you don't have to go from the beginning. You can write similarly. You can write this similarly. Write the other two results. You can say y squared plus z squared over yz is even greater or equal than 2. Z squared plus x squared is even greater or equal than 2. Okay. So here we have the three inequalities. So when you add these three inequalities, you can end up with the answer first, second, and third. Then I can say that x squared plus y squared over xy, y squared plus z squared over yz, z squared plus x squared over xz is greater or equal than 6. Clear? Is it greater? Silence, silence. So equal than 6. Okay, hands up who did this deducing part? The deducing. Okay, good. So let's do one more question. Do this question. I'll write it there. Wait, then leave. Do this one. Q. When x is a positive one, show that xy squared plus xz squared silence is greater or equal than 2xy z. X is positive, show that don't cancel off x. Huh? I'll tell you, you can cancel x here, but I want you to do without cancelling x. X කපන්න නැතුව තමයි මට ගාන හදන්න ඕනේ. Okay, so this is a normal thing. If you take this as xy squared, xz squared minus 2xyz. So here there's a common x, no? So when you take that x out, it's y squared z squared minus 2yz. And then I know what is y squared z squared minus 2yz. Okay, this is the complete square of y minus z. Okay, then what is the expression? The m term is equal to x times y minus z squared. So the question has given that x is positive. So this is anyways greater or equal to 0, but the question has given that this is positive. So since this is positive, you don't have to worry because the product of two positive terms is positive. The product of two positive terms is positive, but since there's an equal mark, use that equal mark. Clear? Okay, so here then what is m? It's xy squared plus xz squared minus 2xyz is greater or equal to 0. When you take this to the other side, I get xy squared xz squared is greater or equal than xyz. So simply, you have to take this to one side and simplify. So what we have to do here is taking x out. So we can get the answer because this is positive and this is positive. Hands up who got this answer. Okay. Then do question number 9, the last question. And the one who asked this question, like when I come near, you can just ask it from me. I'll be coming now. There was a question regarding this half. Like he didn't understand that half thing, like multiplying by half. Do question number 9. And if there's anything unclear, you can ask from me. Question number 9, same thing, same thing, an advanced version. Same thing, no difference. It's an advanced version of what we just did. We have 6xyz. Here it was 2xyz. So take the x term separately and y. Same thing. Sadhana Uttarakhand. Hands up who got the answers? Hands up. So without taking the answers, don't talk. Get the answers. Don't make me repeat it. When I give time to think a problem, do that. තනියම ඉදන්න එලවල දානවා පේලියම. I need that discipline in both my single medium class and the English medium class. When I give time to do a problem, think and do it. I told you it's an extended version of the same thing. In this one, if you can separate the x terms, y terms, and z terms, you will be getting the same answer. And then you have to split 6xy z into 3. Then you can get the answer. Think from the previous one, you have to split 6xy z into 3 parts. Minus 2xyz, minus 2xyz, minus 2xyz. That's all. Okay, so this one, question number 9. I'll directly write, no, let's write it. It's x y squared plus yz squared plus zx squared. And then I can't remember the exact order. I'll just write it x z squared yx squared plus zx squared zy squared zy squared is greater or equal than 6xyz. Okay. So take this expression of p, and then it is xy squared yz squared to this xz squared yx squared plus zy squared minus 6xy. So here you can see, you can find x in two ways. In one place it says x squared, but there are some places where x is as x. Okay, so what I do here is I take this x y squared and x z squared together. And then I take y z squared and y x squared together. And then I take zx squared plus zy squared together. And I'm having a minus 6xyz. So I told you, like, that's why when I give a problem and when I give time, I give ample time to think the problem. So I expect you to think and do this. If not, like, I can just give you 1-2 minutes and then move on to the next question. Okay, this is how we have to do this. මොකද මේකේ ගානක් තනියම හදන්න දුන්නාම තනියම හිතන්න. තනියම ගාන දිහා බලද්දම you tend to do certain things. You might not get this thinking at the initial step, but when you're just looking at this, when you're doing this, you get that thought. So that's what I want to that's what I want you to do. Okay, now look at this. We have xy squared and xz squared, and so this is your previous experience. You know, with these two terms, if you have minus 2xyz, you know you can do this, no? Previous experience. With these two terms, if you have a minus 2xyz, you can do the same thing. The කලින් කරපු වැඩේ කරන්න පුළුවන්. So then I'm splitting this minus 6 into 3. So then I can write, I'm putting xy squared, xz squared, minus 2xyz. I'm taking minus 2 of this. Yz squared, yx squared, minus 2xy. I'm taking another 2xy. And then with the last one, I'm taking the remaining 2xy. So I have splitted this minus 6 into 3, minus 2, minus 2, minus 2. Now it is clear. Here, when you take this x out, it's so this part is previous experience, because I know with these two terms, if I have that minus 2xy, I can directly write this. A y squared plus z squared minus 2yz. If I take a y out, z squared, x squared minus 2xy, xz. If I take a z out, x squared plus y squared minus 2xy. Clear? Okay, so then this becomes y minus z squared. This becomes, you can either write as z minus x or x minus z, same, squared, and this is equal to x minus y squared. Okay, so we have end up with this p with the addition of all three positive terms. What is p? It's x into y minus z squared, y into z minus x squared, plus z into x minus y squared. So since x, y, z is positive, they have given that x, y, z is positive, but we have these square terms. Each of these term is equal or greater than 0 because there's a square. So when we have the addition of three positive numbers, it's positive, no? P is greater or equal to 0. I'll directly write the answer. So after this, we can directly write the answer. So you have to write this one, but I'll write it directly. xy squared plus yz squared plus zx squared plus x z squared, yx squared, and zy squared is greater or equal than 6xyz. So you're solving this using your previous experience. Okay, so there was a question like this. Look at this. So when we were solving this problem, a squared plus b squared minus ab, I think some of the students even might have done in this way, but they didn't realize the issue here. So what they have done, so they have written this in this way. So we have minus ab, you know. So they have taken this as minus 2ab, but there's an additional minus ab. To take it out, they have put this plus ab. So now it is okay, minus 2ab plus ab is again minus ab. So it's mathematically correct. Clear? So here it was minus ab. They have taken it as minus 2ab. Minus 2a minus ab කෙනෙක් අතින් දාගෙන. අයක අයින් කරලා. And then they have considered, okay, this is, it's clear, it's a minus b squared. Okay, so it's a minus b squared. Then what can you say? That p is equal to a minus b squared plus ab. And then they have taken that this is a square, it's positive or greater or equal than 0. And this one, even they have considered it 0. Okay. I admit this is greater or equal than 0. That is a square. No? How can you say that AB product is greater than, it's a positive number? AB are real numbers. So when AB are real numbers, is the AB product positive all time? So you can't say about that. And so මතක තියාගන්න මේකේ you can say a particular term is positive only if it is a square or if it is like plus 2 වගේ තියෙනවා නම් then you can say it's positive. So in this case you can only say that it is positive when it is a square. But there is a special case. අපි කියමුකෝ නිකන් the question have been given that AB are real positive real numbers. The question has given that AB are positive numbers. In that special case, AB can be considered as, tell me AB can be considered as, can talk, AB can considered as positive. So even here, it's a real case. So even here, a special case. This one you can say it's positive. That I admit. But you can't say that this is positive, but this is positive because in this, because they have given that it's positive. Clear? So as a summary, you can only say it's positive if it is a square or if it is plus someone, plus 1, plus 2, plus 3, plus someone. If not, if it is something like plus A, plus B, you can't say these are positive unless it has been given as positive. Clear? Okay, then take a quick break and come by 4:40. We'll be giving the paper by sharply by 4:45. So take a break and come by 4:40.